Continue my discussion of polynomials. Last time we talked about how if you have an equation of a first degree polynomial, that is something of the form y equals a1x plus a0, the equation of a straight line, that any 2 points will completely determine the value of the constants a1 and a0. So we only need 2 points to determine those constants. A1 and A0. And that's what we talked about last time. And uh, for a second order polynomial, as you might guess, is we have 3 points we can completely determine the 3 coefficients of a second order polynomial, A2, A1, and A0. But before I talk about that, let's just first consider a special polynomial. Let's say we have a y equal to x squared plus x plus 1. So in this case, all 3 coefficients, a2, a1, and a0, all 3 coefficients are equal to 1. So I can plot that on my grapher here. Let me pull up my grapher. I want y equal x squared plus x plus 1, and I'll plot it. Now notice that this polynomial, this parabola, which is what I get when I plot a second order polynomial, this parabola does not intersect the x-axis anywhere. In other words, there's no real value of x that makes y equal 0. However, we have previously discussed that if we take, instead of having this be y equal x squared plus x plus 1, if we allow the variable x to be complex valued, not simply real valued. So if we're looking at something like p sub 2 of z, second order polynomial of z, z equals z squared plus z plus 1, that this polynomial will have 2 roots, but the roots may be complex valued. Again, recall I said that any polynomial where the highest order is odd will have at least 1 real root, but we are not guaranteed that we will have any real roots if the highest order is even. So in particular, let's plot out this polynomial for complex valued z and see what we have. In that case, we have something that looks like this right here. Okay, the real axis is this axis right along here. Notice there's nowhere along here where that polynomial equals 0. However, there are values, complex values, here, and this is the y-axis, where that polynomial does equal 0. If we look on the x-axis, notice that we have something that looks like that parabola. Okay, up, it goes just like that parabola that we see when we're looking just along the real axis. So indeed, this polynomial does have 2 roots, but they're not real roots. So keep that in mind. Again, I can't emphasize that enough times. So let's see how 3 points, having 3 points, will in fact determine the 3 constants a2, a1, and a0. So suppose I want to find the polynomial that goes through the point 0, 0 and goes through the point 1, 1, that's x equal 1, y equal 1, and it goes through the point x equal 1, let's say x equal negative 1, and y equal 1. Okay? So goes through the x equals 0, y equals 0, so this will have a real 0, goes through the point 1, 1, and negative 1, 1. So what I do is I look at the equation for this polynomial, and I plug in these points. I plug in x equals 0, y equals 0. Well, y equals 0 says 0 equals a2 times 0 squared is just 0. a1 times 0 is 0, so I have 0 equal a sub 0. So this is our first constant, a sub 0. Now I'll plug in the point 1, 1. Y is equal to 1, and that is equal to a2 times 1 squared, which is a2, plus a1 times 1, which is a1, and now, as I've said, a0 is equal to 0. At this point here, it's x equal negative 1 and y equals 1. I have 1 equal a2 times negative 1 squared. That's still a2 times 1. And then I have negative 1 times a1. So this is minus a1 like that. So I can add these two equations together to solve for, I get 2 equal to the a1, the negative a1 plus a1 cancels out. So I get 2 equals 2a2, or I get a2 equal 1. So a2 is equal to 1. If a2 is equal to 1, then I look at this first equation right in here. I want to solve this for a1. So I have 1. Look at this first equation. It tells me that 1 equals a2, which I just computed to be 1, plus a1. And this tells me that a1 is equal to 0. So I've just determined that a0 equals 0, a1 is equal to 0, and a2 is equal to 1. So the equation of this polynomial that goes through these 3 points right here is y equal to a2, which is 1 times x squared, and then a1 is 0 and a0 is 0. So I just have y is equal to x squared. Let's plot that out and see if that works. So here's my grapher. Y is equal to x squared gives me this plot. So it goes through the point 0, 0, goes through the point 1, 1, and it goes through the point negative 1, 1. So this curve goes through all 3 of those points. So I have a unique solution to a parabola that goes through this point, and this point. And it's the general equation is of this form, and having 3 points allows me to uniquely solve for the 3 constants in the equation. Okay, more next time.